now being recorded.
Hi, today we'll be presenting our language called Coala. Coala is an imperative language. It is strongly and statically typed, and has static scopes and has a strict evaluation order. The motivation behind this language was to implement the best features of C++ language and also try to go beyond C++ language by implementing garbage collection. We were not able to implement garbage collection, but we were able to implement many features that C++ supports. And we would like to discuss some of the main features that we implemented that go beyond the micro C taught in the class. So the main features in are we have array declaration as well as indexing an array. We also have some new data types and operations. We have also made our declarations more flexible and have the desired control flow. Starting with array declarations.
Yeah. So I think array declaration is one of the most important features that we have provided in our language. So an array is defined using its element type and its size. So if you can see on line 3 here, array int 3, we have initialized it as an array that contains 28, 1 and 99. Then we go ahead and try to access each of its values using square brackets. So this is another feature that we have added, which is to be able to access each element of the array using square brackets indexing. So now you can see that we are accessing each value of the array using the array name is I, so I0, I1, I2. And further, we also have array of bool where each element type is bool. So here you can see we have defined array bool comma 2, which contains two values, true and false, and then we go ahead and print each of its elements as well. So here, if we run it, we can see it's outputting 28, 1, 99 for the first array, and then for the second one, it's outputting 1 and 0 that correspond to true and false respectively. So this is how our array declarations and indexing works. Uh, Another thing that we have added in our language that goes beyond micro C are string data types, character data types, and negative integers and floats. Um, you can see that we have defined our string here as double quotes, best languages, koala, exclamation, exclamation, and we are printing it, so it should get printed. Next, we have defined a carry within single quotes as a dollar sign. And next, we also have negative integers and float values, and we are printing each of these values. So as you can see, each of these values is getting printed. Best language in koala, dollar sign, minus 28, minus 6.101. So all of these values are getting printed. Um, Now operations. So we have also provided two new operations that are not present in micro C. The first one is string concatenation. So we can concatenate two string literals using the hat sign. So here you can see we are concatenating best languages dot 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 with space koala exclamation exclamation, and then we are printing it, and we are also trying to concatenate inside the print statement, and both of these will get printed. And then we have also provided the modulo sign. So here you can see A is 28, B is 6. So when we do A percentage B, 4 should get printed. So let's see if that happens. So yes, we can see that A modulo B 4 is getting printed, and also the strings are getting concatenated and then printed. So the next is declarations, and Loni will talk about it.
So we have made our declarations more flexible than what were present in micro C. So in micro C, we had to first declare all of our variables and then do initialization. But in our language, we can declare as well as assign in the same line, as well as we can declare anywhere in the program, and you don't need to declare all of your variables first. You can declare them anywhere in the program. So as you can see, int x1 is declared and assigned in the same line, and int y2 is declared after we have print statements and three statements. So you can declare it anywhere, and when I run this, you can see that it's correctly assigned, and the correct value is getting printed. Uh, Next, we also support all the basic control flows present in any language. So we have the for loops, which basically take starts at the initial value, and we go up to the value of 5 and keep incrementing it by 1, and we print that value. Furthermore, we have the while loop as well, which for this test case starts at I equal to 5 and then decrements up till 1. Furthermore, we have the if else statements, and each if else statement takes a bool, and then basically, if it's true, it prints it out. And so, in this test case, only one statement is present inside the if block, but in our language, we can have any number of statements as well. So, that functionality is also supported. So, if I run this out, you can see that the for loop prints of values from 0 to 4, the while loop prints value from 5 up till 1, and then since if value is true, it prints the string true. Um, so these were the main features of our language, but there were certain challenges and that we faced along the way, and we learned a lot from them. And we would like to talk about three of the main challenges, which was string arrays and making the declarations flexible. So first, talking about the string data type. Since we wanted to implement strings that could take any number, like the string length could be any number, and we first started out by defining string type, as we were trying to define it as L dot array type, and which required the size from the input, and all of this was getting complicated, and we realized that this would be very easily modeled as a L dot pointer type. And we eventually moved to this implementation, and we were able to implement the normal string as well as perform string concatenations because of this. Furthermore, the array declaration was quite challenging. Mainly, we were able to assign arrays, but the main challenging part was the indexing part, and we struggled to get the correct index value, and we wanted to get the address, and for that we realized that there is a gap pointer available, and we used that to look up our variable and get the required index. We also learned an interesting thing where to index we had to first provide the zeroth index and then provide the actual index that we are looking for, and this is how the underlying implementation of this pointer type works. And yeah, to figure out all of this was quite challenging. And then and then talking about declarations.
Yeah, so in declarations, basically our goal was to make the declarations flexible, like the programmer can declare at any point in the program. He or she doesn't have to always declare everything at the top. So for that, the first thing that we did was we made the symbol table into a hash map instead of a string map, because string map is immutable and a hash map is mutable, so that we can update the symbol table at any time we see a declaration. That was the first thing we did. So once we did that, we expected that our code should work. But a very funny thing that we observed is that in the cement.ml file, where we check a statement list, you can see in this slide on line 160, S concatenate with SL, meaning a statement concatenated with the rest of the list of statements. When we do check statement S concatenate with check statement list SL, for some reason, the check statement list SL it runs first. So basically, the last statements get checked before the first statement. So because of that, if some declaration is in the first statement, it will not get checked. So it will not get added in the symbol table. So that's why, to make sure that the first statement gets checked first, we actually modified this a little bit. I mean, we purposefully checked the first statement first and then the following. And so that's how we fixed this problem. Yeah, that is everything. And thank you so much.